Welcome to Upsana classes. Today in this video, let's know about the Karnaugh maps. So, what is the Karnaugh map? What is the uses of the Karnaugh map? So, Karnaugh maps are used to simplify the Boolean expressions. So, without using the logical losses. Before we used to simplify the any Boolean expression using the logical expressions like loss and theorems like the OR operation, AND operations and De Morgan's theorem. So we used to follow all those, but here there is no need to follow all that rules, that much of rules. Yes, of course, these Karnaugh maps too will have rules, the set of the rules, but not very com- complex than that. It's very easy when comparing to that. So it is a pictorial method to solve the Boolean expressions. So it follows the cells. So depending upon the cells and the grouping, the Karnaugh maps can be solved. So what is the cells and how they are formed? For example, if you have two variables in your expression, means in your Boolean expressions, then you need to draw the four cells. If you are having the three variables in your Boolean expression, then you need to get 8 cells. So that means it follows the 2 power n, means 2 power n, where n is number of variables in an expression. So for example, I told you that two variables, for example AB, then the four cells has to be followed, 0 1 0 1, and Karnaugh maps follow the gray code or 1 bit change code. To the adjacent cell, only 1 bit is changed. If you see here, 0 0 0 0 and 0 1 and 1 0 and 1 1. See, if you see here, only 1 bit, um, either this bit or this bit is changing, okay, but not two bits are changing at a time. So it follows 1 bit change code. And if you see three variables A, B, C, then it will have 2 power 3, which means 8 cells. So you can draw the cells vertically or horizontally, but most of us use horizontal for neat representation. That's it, nothing more than that. So if you see here, A, B. See, for A, as it is only one variable, A, B, C, so three variables, right? So A, B, C. So as it is a one variables, we take 0, 1. As it is two variables, B, C, means we have to take 2 bits to represent the both B and C. So 0, 0, 0, 1, 1, 1 and 1, 0. I told you that it follows the Greek code, I mean 1 bit change code, only 1 bit has to be changed. If you put here 1 0, this, which means 2 bits are changing. See, it's just opposite to the 0 1 is opposite to the 1 0, means 2 bits are added at a time changing. So that's not allowed in the K map. So 1 1 and 1 0. So if you see here, 0 0 0, 0 0 1 and 0 1 1 and 0 1 0. So the numbering is given like that. 0 1 3 2 0 1 2 3 4 5 6 7. See, 0 1 0 means 4, right? 1 0 1 means 5, right? 1 1 1 7, right? Like that. So for 4 bits, I mean 4 variables, 2 power 4, which means 16 cells. 16 cells means 0 0 for represented 2 bits here and 2 bits there. So A, B, C, D. The variables are A, B, C, D I take. So 0 0 0 1 1 1 1 0. The same 0 0 0 1 1 1 1 0. So if you see here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Say 15, at the 15 you get 1, 1, 1, 1, all ones, right? So this is the position number of the cells that we take according to one we change code. So this is the building block buildings of K-map. Let's see the set of the rules that it follows to solve or simplify the Boolean expressions. So rules, what are the rules is that it follows. So groups may not contain zeros for SOP. If you would like to represent the expression in a SOP, then you should not group zeros. If you would like to represent them in POS, then should not group ones. Simple, opposite. And then next, so we can group in 2 power n only. 2 power n only we can group. So 1 you can group means 2 power 0 means 1. So 2 power 1, 2, fine. 2 power 2, 4. But 3 you cannot group. So 2 power 3, 8. But 4, 5, 6, 7 you cannot group. So grouping should be followed by 2 power n order. Okay. And then next, group should be large as possible. You have to group as large as possible. Grouping you have to give. So as large as possible, grouping should be done. And then so cells contain one must be grouped. So cell contain 1 can also be grouped as it follows the 2 power n order. Fine. Then opposite grouping are allowed and corner groupings are also allowed. So what is the opposite grouping and corner groupings? So if you see here, if you have one here and if you have one here, but if you take one commonly, say only one means the large expression you will get. It follows the large expression, right? If you group like this and this, considerably commonly, if you take this commonly means corner grouping, you can reduce the expressions so that you can follow opposite grouping and corner grouping. So corner grouping means, so if you have all ones here and if you have all ones here, of course you can take the 4, but if you see this 4 and this 4 combinedly, if you take, it will get 8 bits. So which also satisfies another rule, as large as possible. So you can group 8 groups rather than 4 groups separately. 4 plus 4, then you can group only one, but it is very large. So you can take complete 8 groups you can take. Hope you understood this. So let's take some examples. If you see here, I have an example. F of A, B, C means 3 variables. How many cells does that it have? 2 power 3 means 8 cells. Okay, fine. So here the expression is summation of 3, 2, 3, 6, 7. Then how to get the expression? So see, so 2 means we have 3, right? So means 3 bits you have to take. 3 bits, as it is having 3 variables, 3 bits take. Okay, fine. Okay, 2. We can represent 2 as 0, 1, 0, right? Fine. 3 as 0, 1, 1. Fine. 6 as 4, 2, 1 means 1, 1, 0. Fine. 7 as 1, 1, 1. Fine. Then how to get the expression means, see here SOP, as it is SOP, it represents the SOP, right? So in sum of products, here A is sorry, 1 is, if 1 is associated with A, then 0 is associated with A bar. Means if you have 1, you can put normally, but if you have zeros, we have to put the bars. So here it is a ABC, ABC, ABC you have to take. So here A, okay fine, but it is a 0, so you have to take A bar. Next it is 1, means B, so fine, that's okay. It is C, okay, C, but it has a 0 in that place, so you have to take C bar. Okay, here A, which is associated with A 0, so you have to put A bar. Okay, so A bar BC plus AB C bar and then ABC. Okay, if you see here, you can take C as a common, right? A bar B, C bar plus C, which is 1, the value is 1, so 1 into something is that something, you have to write A bar B. Okay, fine. If you see here, you can take AB as a common, so AB C bar plus C, so which is 1, fine, fine. Then A bar B plus AB. Here you can take B as a common, so A bar A, which is B. So finally you get a B. Let's check. It is, the expression is for, here we solved by theorems, right? By theorems. Now let's solve by K-maps. Let's solve the same expression using K-maps. Let's see whether we get the B or not. So as it is a 3 variables, you have to take 8 cells. Fine. Okay, 0, 1. Here I present A, here I present BC. Okay, fine. 0, 0, 0, 1, 1, 1, 1, 0. Means 1, 2, sorry, 0, 1, 2, 3, 4, 5, 6 and 7. So fine. So what are the numbers that we have? What are the numbers that we have in an expressions? 2, 3, 6, 7, right? 2, 3, 6, 7. So it is a large group. You can take 2, 2, okay, but there is another rule too. What is that? You have to group as large as possible. So group. Fine. So how to simplify one? How to write that? Means see, as 0, 1, opposite signs, cancel. So if you come here, so 1 in these positions, if you consider, so 1, 0, so you can cancel them. So what are the commonly we are having? 1 with the, in the place of B, it is having, so you take B. Simple, solve B, B, then following all the rules. Simplified. Let's take another one. Here I'll take 11, 12, 13, 14 and 15. Means sigma of 11, 12, 13, 14, 15. So if it is a 15 one, means it represents the 4 variables. How? 2 power 4, which is a 16. So 16 is between the 0 to 15. So 15 is here. So you have to consider, by default you have to consider it is a 4 variable. So no need to ask anyone, is it a 3 variable, 2 variable or 4 variable? It is 4 variable. As it follows, 2 power n means 2 power 4 is equal to 16. So 16 means 0 to 15. So 15 is here. So it is a 4 variable. Fine. Okay. How to simplify? I don't tell this process. It's very quick. Just see. This simply I'll tell here. Okay. So I told you it is a 4 variable. So A, B, 2 variables I am taking here, and C, D here I am taking. So 0, 0, 0, 1, 1, 1, 1, 0. So 0, 0 same as 0, 1, 1, 1, 1, 0. Means 1, 2, 1, 2, sorry, 1, 0, 1, 3, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay. So what are the cell numbers that we have given here in this expression? 11, 12, 13, 14, 15, right? 11, 12, 13, 14 and 15. So grouping should be followed 2 power n order. Fine. And as large as possible. Two main rules. So this grouping I am taking. 4 grouping. Which follows 2 power n2. 1, 2, 3, 4. 2 power 2, 4. Fine. Then how to represent it means, see, if you see above, so 0, 0 can be cancelled by 1, 1. Okay. So 0, 1, 1, 0 can be cancelled. Okay. But if you come here, so there is no need to no things to cancel here. So you have to consider both 1, 1. Means both two variables that we are having here is A, B. Have to consider here. A, B. We should not keep any bars as it is a 1, 1. If any variable is associated with 1, it has to take the same. If it is associated with 0, we have to put the bar to it. And another one we have, so 1. You can take simply 1, but it's very like the rule is we have to take as large as possible. So 1 is small. So let's take 2 grouping. So another point I forgot to tell you. So overlaps can be possible. So you can take overlaps. Overlaps are considered. See here we get an overlap. So see how to take this. You go here. So here 0, 1 cancel them, and the 1, 1 you have to take. So 1, 1 are at the position of A. So A as it is considered with 1. So 1 associated with 1. So you have to take A. Fine. Go up. 1, 1 no need to cancel. There is nothing to cancel. So 1, 1 are associated with the CD. So we take C, D. So the simplified Boolean expression for this expression is AB plus ACD. Okay. This is about the 3 variable and a 4 variable schema. Thank you for watching. Please like, share and subscribe. Hope you understood this.